Hey there guys, so today we're going to determine the integral of this problem that I have right here. Alright, so this is going to be pretty easy. Well, we have the problem, right? We have this problem over here, and we also got the formula. You can find this in any integral formulary that you might have. And if you don't have one, I'll leave you a link in the description. And also, I'm not going to explain where this formula comes from. But if you're really interested in that, I'm also gonna leave you another link so that you can see where this formula comes from. And now, getting back to resolving this problem over here, which is gonna be pretty simple using this formula. First, we need to define what is a, what is v, what is basically the variables here, right? So as you can see, this is slightly different from what we need in the formula. So we're going to modify this. We're not going to change any values, but we're going to redesign the formula to make it perfect for this formula over here, right? So now let's work on it. And the first step here is that we need to have an a square. We don't have an a square here, so we need to make this 8 a square. How we're gonna do that? Pretty simple. First, I'm going to show you that I'm gonna put aside the sixth. You know that this is a simple rule in integral. Whenever you want, you can put aside the constant. So I'm gonna put it at outside the integral. And now I'm going to make that 8 squared because we need the 8 to be squared, right? How are we gonna do that without modifying the values in the problem? Pretty simple. You're just going to put in the 8, put in a square root, and then the square, and there we go. Obviously, algebraically, this is not modifying the values in the problem. Now we're gonna put in the minus sign, and then we need a v. We need a v squared. How are we gonna do that? Well, to do that, we're going to put in the 3t, obviously, and you can see here that we have the square already in the t. But on the other hand, what we can do here is leave it without the square and simply square root the 3, then put in everything in parentheses, and then put in a square. And as you can see, this is not modifying the algebraic values, so this is valid. All right. Now I'm not going to get deeper into this, but this is basically correct. Now the next step is to add the t value over here. And by the way, I'm gonna put over here the values of each variable. So a, we know that is square 8. And we know that v is 3 square rooted, and t. All right. So there we have the two values that we need, and now we need to rewrite the integral by using the value of t or v, whatever you want to call it, on the top. You know, we're just going to substitute. So we know that v or t, if you want to call it, you know, t, v, whatever, we're going to put in here this value, which is 3 square root multiplying t over all this shit over here, right? And there we have it, boys. There we have it. As you can see, this is specifically applying to this formula over here. So now all we gotta do is replace variables. So we're going to go to the next step, and we know that this by the way, we're missing just a one simple step here. We know that t is this, but we anyway need to put in here the 3t, because otherwise we will be affecting the values, the algebraic values, you know. So we're gonna put it like this, and now over here we are going to integrate this over here. Pretty simple. We need to know that 1 over 2a, a is square root of 8. And then we are going to put in the natural logarithm multiplying the absolute value of v, which is, or t, whatever, is 3 square root multiplying t plus a, and all this is divided by the same values, just changing the sign over here, and we add the constant value. And as you can see, we just need to add the 6 over 3 multiplying t, right? So because we got it over here, remember. Now all this is going to give us this pretty simple multiplication over here, which we know that if we multiply all this, it's going to give us 3 times 8, 24 times 2, 48. So it's going to give us 24 square root. So let's just multiply. Let's go ahead. 6, obviously 6 times 1 is 6, and then square of 3 times t multiplying 2 times square root of 8. This is much more simple than it looks. We just multiply directly the square root. The square roots is going to give us 24 square root, and then multiplying 2t. There we have it. And natural logarithm. Sorry. Multiplying the absolute value of all this over here. How we gonna put it in here? Very simple. Just put all the values as it is. Alright. We're gonna put a 3t plus, sorry, I'm getting out of the screen. So we said that it's going to be just this, right? 3 multiplying t plus, well, actually I'm gonna put the t first, all right, just to make it more clear about what we are doing here. This is adding 8. Sorry. Just making it hard for you, alright? This is adding 8. There we go. This looks much better. And we just need to repeat this pattern. T, right? And this is summing up this over here. Perfect. There we have it. And this is the answer. All right, this over here is the answer to all your problems. Nah, just kidding, but this is the definite solution for this indefinite integral. That sounds like kind of funny. But if you have any questions, please let me know in the comments. I'll be checking them. I'm gonna start off uploading a lot of problem solving and mathematical physics, anything that comes up to my mind and that you comment in the videos. I'm gonna consider it to to give it a shot by uploading the videos. And please subscribe and support by giving a like button to the video. So that is everything for now. Ciao.